We are looking at a negative feedback configuration again. Here, what we again need to do is find what is the V plus voltage. So first step, it is equal to 2 volts. And we say the V minus has to equal to V plus, it's equal to 2 volts. 2 volts here. Then we write our node voltage equations. In this case, we have only one. So we write 2 volts minus 0 volts divided by 1 kilo ohm. This is the current that is running through this way. Plus 2 volts minus 1 volt divided by 1 kilo ohm. That is the current running this way. Plus we have 2 volts minus V out over 10 kilo ohms is equal to 0. So that's the current going this way. I have not specified the supply voltages. For this case, you can assume that I have plus 20 volts, minus 20 volts. So in every op amp circuit, you have to have power on this op amp, otherwise the operation amplifier doesn't function. So looking at this, what do we have? The kilo ohms cancel. It's common to everything. So what we have here is 2 volts plus 1 volt plus 2 volts over 10 equals to V out over 10. So what does this make? This makes 3 volts here. So if you do the same common denominator for everything, so you multiply the whole equation by 10, right? What we end up having is 30 volts plus 2 volts equals to V out. So V out equals to 32 volts. Now we need to check the saturation condition. Is this more or less than our supply lines? So 32 volts is actually more than 20 volts, which is my positive supply. So I will say V out becomes 20 volts positive saturation.